Hello everyone, can you hear me at the back all right? Okay, I've been teaching GCSE Astronomy in various different guises for about the last 20 years. I've seen it evolve, and I've got some idea about the background to where we've got to now, and what I'm going to try and do is take you through where I think we're going to next. Okay, Carl Sagan, he said, you have to know the past to understand the present. And Theodore Roosevelt said, the more you know about the past, the better prepared you are for the future. So my thesis is, if you want to know where we're going with astronomy next, you really have to know where are we now, where have we come from, what motivated it, what applies, and where can we go. I'm one of the astronomers at Caradon Observatory. This is run by 3 or 4 of us who have got a really keen field that we want to allow as many people as possible to find out about astronomy and space generally. So we have got a multi-dome site. We're about 10 minutes north of Liskeard. We try to get state-of-the-art facilities. We've also got a lecture room, and we've got accommodation up over there where people can come and stay. We put on displays during the day, and of course, we've got our nighttime telescopes. Now, you might look at that and think, well, that's all very well, so you just turned up and you took over this observatory. Well, it wasn't quite like that. When it started off life, there was a pig house, and the pig house was knocked down, but we did use the foundations, and we created the 4 principal domes that are in Caradon. We also wanted somewhere where we could talk to people who were interested in there, which we called the lecture theatre, which started out as the turkey house and has somewhat evolved to that. And then we had the row of pig buildings, and we thought that's probably not entirely satisfactory for astronomers to come and stay there. So those are our accommodation lodges. So that's basically what we've got at Caradon Observatory. Our motto, our mission statement, when we started out doing this, we'd seen other mission statements and they seemed to be long and complicated and a bit cheesy. So we got a very simple one. Our mission statement is, why not? So if somebody says, why do you do astronomy? We say, why not? We'd always try to do the best that we possibly can. So there's inside the there's inside the lecture theatre. And I'm using something called Magic Planet there. And we've also got, sorry, I'm not very good at using this better. And we have open days where people come to find out, to just outreach to people, start them young, try to encourage them. We also try to work as hard as we can to get as good images as possible. So there's a transit of Io passed across in front of Jupiter. There's M42, the Orion Nebula. We'll come back to that in a little while. There's a shot of M51. That's Wayne Thomas, our principal observer, astrophotographer. We also tie in with people doing GCSE Astronomy. And that was one of the images that was requested by one of our students as part of their coursework. We have to make sure when we're doing that we do exactly as they specify, because part of their remit is to say, so how are you going to improve on it? So we thought if we did something that takes 5 hours and then say to them, and we might be dealing with 13 or 14-year-olds, right, go and hit the library for the next fortnight to see if you can work out how to improve on that. So it's one of the things we have to be aware of. There's Bode's Galaxy. And there's, through our solar telescope, taken an image of the sun. So what I've tried to do there is just give an idea of the sort of things that we try to encourage, that we do ourselves, and we try to encourage other people to get involved in. And one of the things that when SpaceX said, we are trying to find a site to locate the radio telescope, would you like to get involved? Our mission statement was, why not? And so we did. So there it is to start off with. Base has been put in. There's the central plinth. And there we build it up. And sorry, I don't know if you can see it, the light's there, but that's a shot trying to show, there's the radio telescope pointing up towards the heavens.
Do you want to go back? We can turn the lights off a sec.
Yes, okay. That's much better. That actually shows, in fact, what I'll do is, if it's all right with people, I'll just run back just a little bit so you can see some of the other pictures that we've got. Right, there's M51. There's the Orion Nebula. And if I'm gentle enough on this, yep, there's Bode's galaxy. It's about 12 million light years away. Kids find this fascinating when they come to look at it. My best way of saying it is, have you ever been to a reservoir, driven there in a car? And they say, well, yes. So we got a local one, Sibley Back. And say, well, when you're looking at Sibley Back, there's probably some raindrops on your window screen, on the window of the car. So most of the things in there are the equivalent of the raindrops on the window, and far beyond is a huge collection, which is an external galaxy. So let's take it through as far as there. But one of the outreach projects that we got involved in was with dark skies. We had come for a long time to realize that the skies over Cornwall were exceptional, and that we should try and find a way of getting this recognized. So we got in touch with the International Dark Skies Association to find out how could we actually get this area of Bodmin Moor, because we are on the extreme edge of Bodmin Moor, was there any way in which you could get a dark skies designation? And they said, yes, but unfortunately, with the sort of thing you're looking for, you are not a big enough entity. What you need to do is to get, minimum size of it would be your county council to get involved. So we stopped getting involved with the Dark Skies Association and got involved with Cornwall Council and guided and enthused them until eventually they were prepared to say, yes, we will form a collaboration with you and we will go to the Dark Skies Association in Tucson in Arizona, and we want to get designation of the Dark Skies Park for Bodmin Moor. And I wish I was more delicate on doing this. Okay, so there's a cut down letter. I don't want you to give the impression that that's all that you send off. That's just saying, there's the council's letter, and there's the start and the end of our letter with the various directors on there signing it off. Just to give you an impression, that's not all you send. In that dark skies landscape, and there's something interesting, when we were trying to get involved with doing this, there were a number of things where they came back and said, we want this checked, we want this checked, we want this checked, and we thought we ticked every box, and then they came back to us and said, there's been a slight delay. And so you're thinking, oh, whatever's up now? What's the next delay? We thought we got this all signed, but it was a rather nice delay. They said, we've just realized that you are a site of outstanding natural beauty, and you're also a site of special scientific interest. And you're the first one in the world who's actually put forward for dark sky status for something that already has those two statuses already. So our committee has decided that we want to create a brand new designation, and we're trying to find what is the appropriate name that we can do. So they got back to us and said, will you please resubmit? And we'd like you to call it a dark skies landscape, and Bodmin Moor is actually the first dark skies landscape in the world. And we have set a precedent, which means other areas now that have got special scientific interest or are particularly beautiful places have had the precedent created with Bodmin Moor. I said to you before, you don't just include that letter. That's actually the letter that went in. It was 145 pages long, and it's a pretty complete document. Thing is, you have to identify. You don't just say, I want to be one of those. And say, great, you've got it. Now what are you going to do to keep it going? So we had to have a rolling program to keep it going. Those were some of the ones that we thought were interesting and of advantage. The scientific advantages: education, enjoyment, health, wildlife, and energy efficiency. All those were included. And what's good about this is they don't say everybody's got to have their light shielded, go back and change everything. But what the council has agreed in Cornwall, I'm sorry if there's anyone in Cornwall from here who's going to get caught by this, but in Cornwall now, you put in an application for upgrading your lighting, or you ask for new lighting, and you've got to conform to the new things that apply across the whole of Bodmin Moor. Okay, so where are we? Well, that's the area that's covered. There's Bodmin, there's Caradon Observatory right on the corner there, and so we coordinate and work with the council on that. And for those of you who are interested from here, you can get to it either by going down the A30 or you can go down the A38, and that includes our friends from Sidmouth. So if you want to come down at any time, please do. Okay, that was setting a bit of what we've done at the moment and why we've done it. Why have we created this infrastructure? Well, we're trying to answer the question, or we know what the answer is, but we're trying to provide evidence for the fact, are young people interested in astronomy? And the answer is, you bet they are. This is at Caradon Observatory when we had one of our opening days, and we had people come in. Obviously, during the day, we can operate the solar telescope. This is not the sort of standard one where they say, I've got this very cheap telescope and this tiny little solar filter that you put on the eyepiece end, which are worse than useless. They're more dangerous than you can imagine. I think the best place for those, perhaps, Patrick Moore once said, the best place for one of those is at the bottom of the fish tank. It might interest the fish and it will certainly deter you from trying to use it. So what we've got is we have got the proper mylar filters on the top end of this, restricting the light that comes in, not trying to compensate with the concentrated light that's coming out at the other end. Sam, can we have the lights down, please, on this? You mentioned about rockets. We sometimes run various sessions where we deal with rockets. We had to also coordinate with the local fire brigade, etc. But it was rather nice that we had some youngsters who came out there, worked on a project with us, and it's perhaps not terribly clear over there what's going on, but if I manage to get on to the next one, they've actually designed and are building a rocket, which is taking off there. And yes, we did have a parachute on there. We didn't get it back immediately, but about 2 days later, the farmer from 3 farms across said, is this anything to do with you? Because it arrived in my yard 3 days ago. And I was trying to work out who would be weird enough to do that. He said, so he said, so it's just taken me, he said, I was busy for the last couple of days, but I knew where I had to come and do, because if it wasn't you lot, you'd know where it was. Okay. Right, we've also got something called Magic Planet. This is quite an amazing device. It represents something, just checking time yet. One of the biggest problems that we have when you're educating children is they see a world map. They've seen loads of world map. They're in books, they're on the web, they're up on the wall. All right. Most children, by the time they get to secondary school, know exactly what the world map looks like. They know exactly where they are. They can recognize the world on which they live. Biggest problem, of course, is that there is no world map that has yet been created which is not hugely distorted. In fact, the only thing that's accurate on a world map is the equator line. Everything else is wrong, and the further away you go from the equator line, the worse it gets. So what we rather like about this is that we can use some specialist software that was written by Global Imaginations in California. They have worked with NASA, who have got a briefing which says everything that we find out is owned by the American taxpayer. We will publish everything that we can in as many different formats as we can. And Global Imaginations came along and said, we can create a spherical surface. How about you give us all these close-up images that you've got from your planets? We will actually create undistorted pictures of what all the planetary surfaces look like and the major moons. And this is what we've got. Now, I think that's fascinating, but I think what's also interesting on there is how interested the kids are there. These are not posed, and just to give you some idea about what I'm talking about, these are all GCSE Astronomy students. Most of you know GCSE is done in year 11 under normal circumstances. Well, not with the way we do GCSE Astronomy. The kids start it in year 7 and they can take it when they like. I've had no children so far who have opted to take it in the end of year 7, because they normally ask me a question, can I take it in year 7? And I say yes. And they say, if we do an extra year, will I do better? And I say yes, because I think it takes a couple of years to really get to there. You want to see the spring on the step it takes when you've got a kid going into year 9 who has just taken a full GCSE in astronomy in their back pocket already. I speak to other teachers and say, we can tell the astronomy students, they come in to start their GCSE with such confidence. Unlike others who are saying, can I do this? the general approach for the successful astronomers is saying, is there any reason why I can't do this? And it does make a difference. Just to give you some idea, these two lads here, right, Alex and Barney, they actually did their GCSE in year 9. They said, well, we don't want to stop now. What can we do? Can we do A-level? I said, there is no A-level. Said, the only thing there is a cosmology module in A-level physics. I said, great. Can we do the cosmology module in A-level physics? So I said, yes, you do realize that it's only part of an A-level, and you won't get the rest of the A-level as well. I said, we don't care. We just want to do it for fun. So we had two year 10 lads here who did a year 13 cosmology module, which they passed. They failed the A-level physics because they didn't do any other modules, and they were entirely happy with it. We got kids who are so wound up with astronomy, they really love it. They really do. Okay, anything further afield? Well, that's the ING, the Isaac Newton group of telescopes in La Palma, the Canary Isles. And as you look across the sea, please note that that is not the sea, that's the top of the clouds. Now, back in 2000, I had some kids, because before I was teaching astronomy in Liskeard School, which is where I teach GCSE Astronomy, I was actually part of the Cornwall School's astronomy project, which 2 other teachers and me set this thing up, and we got an invite to, what about taking some children down here? Because we'd liaised with this on a separate, but with them on a separate project. And they said, what are you doing with these kids? They are very young and they seem to know an awful lot. What about do you want to bring some kids down here? We could see if we can get some time for you. I said, yeah, we would actually love to do this. So we actually worked on, that's the Jacobus Captain telescope up there, and that's the one that we worked on. So there are a couple of our students working on the Jacobus Captain telescope. There's one of the images that they produced. They were both 13 years old at that stage. And the rationale was, there are some exceptional astronomers here. What about being the first in the world to offer them telescope time? Funnily enough, just checking time, yes. Funnily enough, when they came back to us and said, look, we're terribly sorry. We've just checked our charter. We have got absolutely no facilities for children at all, so we can't do it. I'm terribly sorry. And I said, that's a real, real shame, because the kids would love to do that. He said, we would love to do it. But I mean, the only way we could do it, would they be happy if they had the status of visiting an astronomer? So I spoke to the kids and said, how would you feel about going to visit this place as a visiting astronomer? And they thought about it for getting on for a tenth of a second and said, yeah, yes, please. So we went down there. So that was what we did in 2000. The following year, of course, we couldn't do this again. You can't be first for a second year. So we had to try and find a different way and wanted to take them down. So there they are again. All right, so we got some of them there working, and funny enough, when I mentioned this to Sam, Sam said, I recognize that control bank because I've been down working at the ING. So that is for real. And there we are, and I'm afraid that one there, I'm afraid there's me looking somewhat younger than I am now, probably a little less harassed. But there they are. And the rationale that we used was the next generation of astronomers are at school now. So why didn't you want to be would you like to be the first in the world to allow the next generation of astronomers to come and work on your telescopes? And they said, based on last year, yeah, we will have you down. They were brilliant, these kids were. They were absolutely fantastic. And I say that because partway through, they had an emergency project came through. Whenever you get booked telescope time, you have to allow for the fact that there could be an hour or an hour and a half when an emergency project comes through. And it just so happened on the night when we were there, that happened. So my kids, who had already impressed the ING staff, because the first day you learn the computer programs. Now, I don't know if how many of you are familiar with just how quickly kids devour IT understanding. So we went through the first day, and after an hour and a half, the kids were fully aware of how to operate all the systems. And the guy who was there, our contact there called Javier, he said, we've never had anybody pick up these systems this fast. Astronomers normally take all day to understand what's going on. How's this happening? I said, have you ever had any kids here learning to use IT before? And he said, no. He said, well, you have now. So that's where we were with that one. One thing that I've mentioned, and it's true, is that astronomy qualifications for young people, there's only a GCSE in astronomy. It's only run by one exam board. I wish it was done by more, and there's no A-level astronomy, and I wish there was, because there are enough kids who are interested in doing this. So, where are we at? I said you've got to look at the past, see where you are now to work out where you're going to go in the future. Well, that's when we started. And what I've listed there is the total number of candidates who are taking the exams, plus in blue the number from schools. So at the start, it was looking pretty good. It then shot up to about 2013. Things are looking really good there. It's up by a factor of, well, in 2002, it was below 500, and we're now close up to 3,000. We need to be aware of what's happened since. That's what has happened since. Now, I think there's a thesis there which says it's not a lack of enthusiasm for the kids to do this. I run GCSE Astronomy after school, and I get kids turn up at the end of a school day for another 2 hours worth of study, voluntarily. So let's just break that down a little. Is there a difference between boys and girls? Well, traditionally, there are more boys that tend to do it than girls, but it's not a minority interest for girls. What about the spread across the different institutions? Well, you can see that the total number taking it is in blue, most of which are people at school. There are others in private or external entries or further education. But by and large, if you want to solve the next generation problem, you need to solve it in schools. So, what are the problems with how astronomy is taught in school? Now, I've got a bit of a bee in my bonnet about this, and I'm going to share it with you. I hope you're all right with this. First of all, we are encouraged to present important things in a simplistic way for children because they cannot understand complicated systems. That is a fallacy, and it causes us major problems. Not with the normal stuff where you learn at school, which is you're learning about the science or the literature or the history of the Earth's surface and what's happened on the Earth's surface. I get my bee in my bonnet about this. Isaac Newton, and he talked quite correctly about the acceleration of an object depends on the mass and the amount of force applied. Which, as you get on, you realize that that is absolutely true, and every spacecraft that travels and everything else ties in with that law. My concern is the way that it's taught. So there's my little setup. Says the teacher is saying, Newton found that things require acceleration. Sorry, they require a force to accelerate, but you don't need a force to maintain a constant speed. And so your pupils there are saying, hang on a minute, just a minute. And the teacher will then say, don't argue. Isaac Newton was a very important scientist. I told you this lesson, last lesson, the previous lesson. Why don't you understand this? Not realizing that what the kids are thinking is this. Well, here I am in Exeter, and there's London. So according to Newton, if I go up the M5 and head off to London, I only need petrol while I accelerate up to 70 miles an hour. Then I can coast all the way to London. Now, it's no good for kids who have got that internal message coming back and saying, but Isaac Newton, don't argue, Isaac Newton was a very important scientist, and if he was here today, he would see how important his work still is. Not realizing what the kids are whispering to one another is, Isaac Newton was some bloke who's been dead for 300 years, and what's more, if he was here today, his car would probably keep running out of petrol and he'd be late for everything. If you want to take children forward, you have got to start where they are and move them forwards. Okay. Oh, incidentally, I just slipped this slide in. I think, yes, I've got time for it. I slipped this one in. Some years ago, I had gone with a group of teachers to NASA to get some teaching materials and brought it back. And one of the things they said was, it's a good idea to establish what the kids know already. And we want to use multiple choice, but the trouble with multiple choice is if you ask somebody a question and the correct answer is answer C, Everyone who knows it's C will score, and everyone who guesses it's one of them and just randomly chooses C will get it right. So we tried to set this up where we asked for different concepts in different ways, and just looked at the ones where the different questions over the same concept, we looked to see which students really understand the concept and which one does it appear to be random. It was interesting. They believe, yes, that aliens exist. Would anyone like to guess the answer to the follow-up question? We had loads of different answers, but the most common one. Anyone like to make a guess as to why young people believe that aliens exist? Well, there it is. Hollywood would not spend so much money on things that don't exist. Hollywood do spend a lot of money on films, therefore they must exist. You're going to think that I'm picking on Newton. No, I'm not. His is such a fundamentally important thing. We got to make sure that children are taught it in a way that makes sense, and it's not Earth-based. It's got to work on Earth and everywhere else as well. So he came out with this universal formula. That's a formula that's used in every rocket or spacecraft that goes to any planet anywhere else. Right? We've got to be able to deal with this. Unfortunately, to make it simple, that's how children are normally taught. What force holds us to the Earth, gravity or weight? It's a nice way to work. It's a nice way of introducing it. Later on, we try and substitute that. Weight is a force caused by gravity. The weight of an object is a gravitational force between the object and the Earth. I have to say, I still don't think that's sufficient for getting the idea across. And my reason is for this, to try and represent this. First of all, we ask children, what do you understand? What holds you to the surface? So, well, weight does. Oh, we've also learned that's also gravity. Great. What have you got? What about this? What about spacemen out in space? What can you tell me about them? Oh, they're weightless. Unfortunately, they put two and two together, and they will conclude that as well. Then you've got a real problem. Because if you then pursue it and say, okay, so what's the difference? Where does one change into the other? They say, is it when the air runs out? Seems to make sense. Airplanes up in the air, running out of fuel or whatever, will crash back down to ground. But stuff out in space, even the International Space Station, floats out in space. So without being guided to what they're learning, they're going to come out with that. The interesting one is when you ask them, so what about that? What keeps the moon in orbit? And they'll come back with an answer. It's gravity. How does that work? How the hell does that work? We've got a gravity field, then no gravity, then gravity. Ah, the moon is big. The moon's big enough to have gravity, whereas the International Space Station and spacemen don't. And it all comes back to this idea of making it simple in primary schools and saying gravity and weight are the same thing, and they're not. Let's just, sorry? 5 minutes. 5 minutes, okay. Just to make it a bit quicker on this, going down, I'll run through this very quickly. You must have been in a lift. If you believe that that is true and that's the full story, without anything else, you get in a lift going down and your weight will actually get less. You go up and your weight will increase. Shooting through this rather quickly. So we've got to be careful that we would like to be the ones on the left, but we want to make sure kids don't think they're the one on the right. Okay, let's just go through. So what really inspires young astronomers? Life, the universe, and everything. Thank you, Douglas Adams. And here I thought I'd just give you a couple of examples. First of all, if we show kids things like that, our problem is that gives the impression the Earth is very close to the sun. So there's the Earth, there's the sun. If you pose a question to them saying, you're not used to using rockets, and light may only take 8 minutes, but suppose you use something that you like, that you're used to, like a train. Suppose you were to send a train to the sun, how long would it take? Intercity 125, unstopping, how long does it take? You ask most people, and they say, well, yeah, I know it's not going to be 8 minutes. It's going to take weeks, probably months to get there, assuming you were to go without stopping. the interesting thing is, the answer is 85 years. Kids need to get their answer right. The sun might be close, but that doesn't mean it's really close. It's relatively speaking close. It's still 85 years away on a train. What about M42? We saw that one earlier. Diameter 24 light years. But that doesn't mean much. Kids don't quite understand what that is. So what's understandable units? This is what kids are fascinated by. You put it in like cubic miles. Anyone know what that's going to come out to be? It's 1.4 million cubic miles. The universe is a big place out there and kids love it. Voyager 2 might have taken 12 years to get to Neptune, but it's not stopping, it's going on. It's actually scheduled to get to Sirius in 285,000 years, and kids love that as well. They also love the fact that M31, light takes 2.25 million light years. When it's made 99.9% of its journey, Julius Caesar was looking at the White Cliffs of Dover and thinking about invading. Or if you look like another one, that's when Jesus was giving the Sermon on the Mount. This is big out there, it really is. What about jobs, just to finish off on this? 30,000 jobs in the space industry in the UK. What about the future? According to this most recent government thing, which is 2 years out of date, we're estimating 100,000 jobs by 2030. So what do we need to do to educate the next astronomers? We need a fabulous subject, we've got it. We need fascinating research, we've got it. We need enthusiastic kids, we've got it. What we need is them, to work with them, to produce something that really works, that schools can work with to offer to our astronomers, and put in all that together with our enthusiastic astronomers, we end up with the next generation of astronomers. Thank you.